I am Anil Kumar. Welcome to my series on polynomials. Let me thank all the viewers and subscribers of YouTube channel who are watching my videos, posting brilliant remarks and some excellent questions. If you want to learn from me, you can always send an email on the address given. In previous days, I've got few inquiries about how do we find the complex roots of a polynomial. Based on the questions received, here is one. An example which will help you understand solution of questions regarding the same. So we'll discuss how do we find complex roots of a polynomial in this particular video. Question here is the polynomial p of z. So when we write z, it is supposed to be a complex number. So z to the power of 4 minus 8z cubed plus 48z squared minus 176z plus 260, where z belongs to set of complex numbers, has a root at z equals to 3 minus I. Find all other roots of the polynomial pz. So when I say I, it really means what? So I means it's equal to square root of minus 1, right? That's the set of complex number. Or you can also say, that I square is equal to minus 1. Okay? So that is how it is. I'd like you to pause the video, answer this question, and then look into my suggestions. Let me begin with the basic concept. So we are saying that one of the root is at z equals to 3 minus I, correct? As you know, the complex roots are always in conjugate pairs, right? So remember, complex roots are in conjugate pairs. What does that mean? It means if one root is at 3 minus I, the other root will be at 3 plus I, the conjugate of that, correct? Now, once we know that there are these two roots, we can multiply this by their factor. So root basically means I could write this as z minus 3 minus I as one of the factors. The other will be z minus 3 plus I, correct? So if I multiply these two factors, I'll get my quadratic term, correct? You can say quadratic factor, correct? So one of the quadratic factors will be there. We are working with a quartic equation. Do you see degree 4? So this is a quartic equation. We can say quartic polynomial. So if I divide this by a quadratic factor, in that case, the other factor will be a quadratic factor, and then we can use the quadratic formula, right? So we'll do division. And that will give us the other roots. Using quadratic formula, is that clear to you? So the concept is absolutely clear. I'd like you to now pause the video, do the needful. Mainly, you now know that there are two roots given to you, 3 minus I and 3 plus I. Just multiply these two factors, get a quadratic factor, perform the long division, correct? And then get the roots. Let's begin. So first thing first, we'll try to find what is the quadratic factor, and then we'll further go with division. So as I was saying, the complex roots are in conjugate pairs. So if we know that 3 minus I is one of the roots, in that case, the other root is 3 plus I. So that means z minus 3 minus I and z minus 3 plus I are the two factors. Let's multiply these two factors to get the quadratic factor. Perfect. That's the summary of what we discussed. So let's now do the division. So first step first, open this bracket. So you get z minus 3 plus I and z minus 3 minus I. Now it becomes very simple to multiply, right? You know what is a square minus b square equals to, right? It is a plus b times a minus b. And we have used this property here. And so we got a, which is z minus 3, and b, which is I. So we get z minus 3 whole square minus I square. Now expand this, expanding using the formula. As you know, a plus b, rather I may write a minus b, since we have minus in this case, whole square is equals to what? A square minus 2ab plus b square. And that's what we did. So a square is z square minus 2ab gives me 6z minus plus 9. And what is I square? Well, I square is minus 1, and therefore minus and minus becomes plus 1. Adding 1 to 9, we get 10, and we do have the other quadratic factor, which is z square minus 6z plus 10, right? Where z is a complex number. Is this clear to you? Have a good look at it. Try to understand how did we find the quadratic factor using the two roots and these two complex roots at 3 minus I and 3 plus I, correct? Now we need to perform division. Let's perform long division to find the other factor, right? So that's what we are going to do now. So now we are doing long division. So this is the step. We are doing long division. Let me write down long division. So we have z to the power of 4 minus 8z cubed plus 48z square minus 176z plus 260. So we are performing this division now. Let me write down the normal symbol for division. Right. And we are going to divide this by the factor z square minus 6z plus 10. Performing the long division, first multiplying by z square goes into the quotient, and then we have the terms z to the power of 4 minus 6z cubed plus 10z square when we multiply this z square with all the terms, right? Now you take away, so when you take away, you get minus 2z cubed plus 38z square minus 176z. To get rid of minus 2z cubed, we'll take the quotient as minus 2z. So we get minus 2z cubed here, the other terms being plus 12z squared minus 20z. Now take away this. So when you take away, what do you get? You get 26z squared minus 156. Bring down the constant 260. And now we need to have 26 on the quotient. So the next term will be plus 26, which gives you plus 26z squared minus 156z 260. And as expected, the remainder is 0, right? So that means we have the other factor, which is z squared minus 2z plus 26. So that is how we could now factor the given polynomial in terms of two quadratic factors, one for which we were already given the complex roots and the other one which we just found. To find the other remaining roots, we can actually use the quadratic formula here and factor this, correct? So now the next step is to use quadratic formula. And then factor. So that's what we are going to do now. As a quick reminder, if the equation is of the form ax squared plus bx plus c equals to 0, in that case the quadratic formula is x equals to minus b plus minus square root of b squared minus 4ac over 2a. We are working in the set of complex numbers where I squared is minus 1 or I is minus 1 square root, correct? So our equation to work with is z squared minus 2z plus 26, where a is 1, b is minus 2, and c is 26. Substituting the values minus of 2 as b, right, and then b squared minus 4ac in the term 4 times a times c over 2a, we get the values. Simplify them, so you get 2 plus minus square root of minus 100, which is 4 minus 4 times 26, Okay, 4 minus 104. We get minus 100 within the square root. That minus square root is negative 1 square root is I, the iota, the complex number I. So we get 2 plus minus 10I over 2, which when divided by 2 gives us the other roots. Add 1 plus minus 5I, correct? So that is how you find all the four complex roots for the given polynomial. Correct? So we can now write down that the roots are 3 plus minus I and 1 plus minus 5I. So I hope these steps are absolutely clear. Feel free to write your comments, share your views, and if you like and subscribe to my videos, that'd be great. You can always watch my latest videos on the website globalmathsinstitute.com. And if you have any questions, you can always email me your questions. Thanks for your time and all the best.